The spear is thrown off a high ledge with the givens shown in the picture to the right. How much time does it take to get to apogee? Neglect the height of the person throwing the sphere. So remember, we define apogee as the point in the motion that's the highest from the starting point and has a vertical velocity of 0. So in this problem, what I'm looking for is the point that's right here. All right, first step in the solution before actually getting to any of the math problem is drawing a triangle to show the initial setup, the initial velocity. Here's my triangle down here in the bottom of the screen, right down there. And I've got my horizontal velocity to be 25 cosine 60 and my vertical velocity to be 25 sine 60. This is always the first step if you're given an initial velocity at an angle, is to make a triangle. If it's not at an angle, then you don't need the triangle, but this one is at an angle, so we'll do the triangle. Alright, so there's my velocity, there's my angles with the velocities. Next step is to fill out my table. So I have two accelerations, which means I'm going to have two lists of givens. I'm going to slide this down so we can see what's in the table. Now, one thing that's going to be different about this from some of the previous problems is the fact that the problem says apogee. And we know the condition for apogee is where the vertical velocity is equal to 0. So I'm going to make the vertical velocity equal to 0 in this problem. And I'm doing that because that's the defined condition for apogee as well as being the highest point. Now what I need to do is I need to use these three givens in the vertical column to find out how much time it's going to take to reach apogee. I won't use the horizontal column because I don't have enough givens in the horizontal column to do any good. So in this problem, I'm looking for an equation that has v naught x, v, and a in it. That's going to be v naught t, v, and a in it. Sticking only to the vertical column, highlight that. And then down here, that's going to be the v equals v naught plus at. Putting in my numbers, I get a positive 25 meters per second sine 60, and I get a negative 9.8 because it's going down. And then I solve that for the time, and I get 2.21 seconds. So it takes 2.21 seconds to reach apogee.